and I'll be your host for today's session when we're going to talk about how we use real user monitoring for our own Sumo Logic platform to monitor its front end and digital experience of you, our users, our customers. Together with me, we have today one of our best front-end engineers and at the same time engineering manager, Miłosz Piechocki. Miłosz, what are your day-to-day responsibilities in Sumo?
Hi, Pavel. I'm an engineering manager at Sumo. I'm leading the front-end development of our troubleshooting workflow. That includes areas such as alert response page or entity inspector. And I have also been involved in initiatives around improving the performance of our front-end. And that's when I had a chance to dogfoot our real user monitoring solution.
Thank you, Miłosz. So you have picked 4 scenarios for us for this session. Can you quickly introduce us to them and explain why they're important for the life of the front-end engineer?
Sure. So our application, our front-end, is based on the single-page application architecture. And these scenarios reflect different aspects that are important to monitoring SPAs. So the first scenario looks into loading the SPA. The second scenario looks into how the SPA communicates with the backend by sending XHR requests. In the first scenario, we look into different interactions that the user performs with the SPA, as we need to make sure that these interactions are very smooth. And finally, in the fourth scenario, we look into monitoring the runtime performance of a particular piece of code, as it can impact the user experience.
All right, so that sounds great. So Miłosz, first scenario is really about the basics. Pages need to load fast from the CDN, from the front-end web server to the client and to its browser. So how can we monitor that with Sumo and find the root cause easily in our product?
Sure. So we can start by opening the Explorer view in Sumo and navigating to the real user monitoring view. Then in the tree on the left side, we can select the application and the service that we want to monitor. In this case, we monitor Prada, which is the name of our UI, the internal name. We click on the document loads node in the tree, and that will cause the dashboard on the right to load. In this dashboard, we are looking for a panel called document load time. And this is a honeycomb visualizations where each honeycomb represents the load time, the average load time of a particular route. I can easily see that one of the honeycombs is significantly darker, which means that one of the routes is loading much longer than the others. I can click on this honeycomb and I can see that this is the route for dashboards in our UI. As I click on it, the right-hand side panel opens up and I'm switching to the Entities tab. The Entities tab allows me to jump to view like different types of data related to this particular data point. So in this case, I'd like to see the traces that contribute to this high load time. I clicked on the traces button and now I can see the trace view, which shows me the list of traces contributing to the load time at this particular point of time for this particular route. I can see some longer traces here, so I choose one of them. And now I can see exactly what happened during the load time of during the load of this particular route. There are a few things standing out here. The first one is that the last resource fetch span occurs quite late in this trace. I can think and see whether I can move this resource fetch request earlier and maybe make it parallel with other spans, and this would allow me to save like 2 seconds of the load time. Another thing that stands out here is this very long resource fetch span that takes more than 11 seconds. I can click on it to see why it took so long. So I can click on this metadata tab here, and here I see a lot of different interesting values for this span. So first of all, I can look at the http.response size field, which tells me that this resource fetch involved transferring 500 kilobytes of data. I can also look at request start and response start fields, response start and response end fields, and it tells me that it was actually the download that took so long, not initiating connection or processing the data. So that could have happened for a user with a slow connection.
So obviously not every user interaction with web frontend is about loading new documents, as here where we have, big elements of the page. Many interactions we typically do with web applications communicate with the backend in the background, right? Can you help us understand this type of browser-server interaction and how to effectively troubleshoot it?
Sure. So again, we start by opening up RUM in Explorer, but this time we will click on the XHR requests node in the tree. In the dashboard on the right side, we look for the XHR timings panel, which shows us a bunch of metrics related to XHR requests. I can see a spike in the time to XHR processing end metric, which looks interesting, so I click on it. Now in the Entities tab, I click on the Traces button to see the traces that contributed to that spike. On the list of traces, I can see that there was a 12-second trace initiated by clicking on a button labeled Add to Library. So let me click on this span on this trace to see more details. So the trace view shows me that almost all of the time of this trace was taken by a single span that was an HTTP post request. I can see here what URL was this request sent to, and I can even see a span from the backend telling me like what backend service took care of processing this request. So as a takeaway from here, I can reach out to the backend team taking care of this service and investigate if there is anything we can do to speed up this endpoint.
Okay, cool. So we actually are able to track all this background communication between the browser and the web server, the infrastructure behind the web server infrastructure in the backend. So you mentioned that XHRs are typically used in single page applications architectures. Is there anything else that is important to monitor for such type of applications?
Sure. So a very important aspect of SPA is navigation between different parts of the application. As we know in an SPA, as the user navigates between different parts, we don't reload the whole page, but instead we dynamically update the relevant portion of the page. And we need to make sure that such navigations are smooth. So we are going to do that in this scenario. So this time in the RUM view, we click on the route changes node in the tree. Now we are looking for the long tasks panel. Long tasks are a great indicator of the smoothness of interactions in an SPA. A long task occurs when the browser needs to process some data or do some calculations for longer than 50 milliseconds. And as JavaScript is a single-threaded language, it means that when it's occupied with some calculations, it cannot update the UI, which results in a very bad experience to the user. because from the user's perspective, the UI is simply frozen and completely unresponsive. Therefore, we need to make sure that we avoid long tasks as much as possible. There are several spikes on this chart, so let's click on one of them. And this time we are going to look at the spans related to this data point. This spans analytic view allows me to specify some additional filters for the span. So in this particular case, I'm interested in long tasks that were longer than 500 milliseconds, which is actually quite a lot, because it means that the browser froze for half a second. I can see 6 spans such as that, so let me click on one of them and open it in the trace view. So here is the complete trace containing this span. This span is selected here. I can see what interaction caused this long task, and it was a navigation to the log search tab in our UI. I can see the ID of the log search, and it is pretty helpful to me as I can log into a customer account and check out this span and try to reproduce this situation on my own machine. I can also see some additional metadata here, the org ID and org name, which tells me which customer was affected. And this particular metadata, these are custom span attributes that we can provide on our own when initializing RUM in our frontend. So this code snippet shows you exactly how to do this. This initialize RUM function comes from our RUM SDK, and it installs a lot of automatic instrumentations that we just talked about, but it also allows certain degree of customizations. For example, we can specify these default attributes as we are doing in this case.
All right, so you're saying that long tasks actually make the browser to freeze, right?
Yes, exactly. As I said, JavaScript is single-threaded, so when the browser is processing the long task, it cannot update the UI, and the result is the browser is frozen.
All right, great. So that's good that we can actually track this. I really hate when my browser is freezing. So thanks a lot. I noticed on your last slide that you're actually adding custom attribute to the data to give it a better context for troubleshooting. I was wondering, can you actually also create completely new custom span for whatever reason the out-of-the-box instrumentation is not granular enough in certain parts of application and you want to be more granular and create your own spans and basically supplement the out-of-the-box spans in a trace with your own custom spans?
Yes, we can do this. And for this, imagine a scenario where you wrote a JavaScript function and you know that in certain cases the execution of this function can be expensive. So this actually happens for us a lot as our UI has to deal with huge volumes of data. We need to process this data and visualize it, for example, as part of dashboards. And in such case, when you can anticipate that the function can be computationally expensive, you can send a custom span representing the execution of such function. It is very simple to do. All you have to do is to wrap this function call with the with span function that also comes from our SDK. And this will cause a custom span to be sent on every call to this function. And the duration of this span will represent the time it took to execute this function. And we can also add custom attributes to this span. And in this case, we are passing some attributes that are based on the input of this function. So this could be very helpful, as this will give me some indication for what inputs the function takes long to execute. Now, let's say I added this instrumentation and I'd like to see the spans in Sumo. So again, we'll use the spans analytics view, and I need to specify some filters. So I will filter by operation using the name that I provided for the with span function. And I will also add a filter for the duration, so that I only see function calls that took more than half a second. And I can see that one of such calls took more than 1 second. So I click on it. I open it in trace view. And now I can see the complete trace with this function call highlighted. So again, there is a lot of useful information here. First of all, I can see what interaction caused this function call to occur. And I can see that it was a navigation to some particular dashboard. I can also see the values of the custom attributes that I specified, series count and visual settings type, which gives me some indication like what inputs caused this function to take so long. I can also see that there is a parent span of this span that is also a custom span representing a function call, but from another UI module, as it is in a different color. So with all this information, it's much easier for me to figure out why this function took so long and find some areas for improvement.
All right, viewers, thanks a lot. That was great, really great for scenarios, how to troubleshoot and ensure that our digital experience of our users are really top-notch. Thanks for walking us through these examples. I'm sure that those of you that, like us, care about perfect experiences of your clients will find these insights very useful. In case you're interested in more details about Sumo Logic Real User Monitoring, please use these links or scan the QR codes here from that screen that can lead you to more materials where you can read about that. In the meantime, that would be all from us. Thank you very much. I hope you enjoyed it, and see you soon.